Well, hey everybody, good morning. Delighted you could join us, and super excited to be back at Q2B and for AWS to be sponsoring Q2B again. This is truly one of the best conferences of the year. We love to get together with all of you, our customers and our partners, and just kind of recap the year that was and kind of look back at what we did in 2023 together, what's coming up next year, and kind of have a bit of a discussion about what's working and what's not working with our customers, so that we can continue to improve quantum computing in the cloud. So our customers drive everything that we do at AWS. And throughout today, I'll talk through a whole bunch of customer examples about work that we're doing on Amazon Braket, our cloud service. And roughly, I'd sort of divide up our customers into 4 personas. So the primary group that's working with Braket today are researchers. They are scientists at universities and national labs and inside companies that are using Braket to do science. So the primary purpose of quantum computing today in the cloud is to drive high quality science so that we can learn how to build better quantum computers. But we're also working with startup companies and solution providers that are building on top of AWS and starting to find their product market fit, how to refine their algorithms, and thinking about the intellectual property that they're going to need in the future as computers become more performant. We've also got solution integrators that we work with, large-scale global systems integrators, and also enterprise companies. So the big customers of AWS that build on top of our infrastructure for all their heavy workloads, they look to us to find a pathway to quantum computing for the future. And so I'll talk about all of those personas throughout the conversation today. Click, there we go. So quantum technologies at AWS falls into 5 pillars of activity. The first 2 are research centers. So we've got a research center based in Pasadena on the campus of Caltech. That's where we are building our own quantum computer. I'll show you a little bit more about that in a second. In Boston, connected to Harvard University, we've got the AWS Center for Quantum Networking. That's where we're researching how to move quantum information around. How do we connect quantum computers together inside the cloud, connect to our customers outside of the cloud, look at technologies around security and communication. The Quantum Solutions Lab is the professional services team that engages directly with customers. I've got a couple of examples of their work today. We've also got the partner network. So these are all the startups and solution providers that build on top of AWS, and we help them go to market and connect with the big customers of AWS as well. And of course, Braket itself. So Braket is our quantum computing service. I'll talk a lot more about that and some of the features that we've released recently. So AWS Center for Quantum Computing, we're building our own hardware. It's a superconducting approach to quantum computing. You heard John Preskill this morning talk about how the pathway to value for hardware is likely to come through fault-tolerant quantum computing. And that's exactly the pathway that we're taking. So at the AWS Center for Quantum Computing, we are focused on building a fault-tolerant quantum computer, introducing technologies around error correction and error mitigation, and we hope to be one of the first to be able to launch a fault-tolerant quantum computer in the cloud. It's going to take a while. This is a long-term, really hard effort. A lot of resources being applied to this, but we're making some steady progress along the way. And just last week at our big reInvent conference in Las Vegas, Peter DeSantis, who's our Senior Vice President of Utility Computing, in his keynote presentation, talked a bit about our progress towards a logical qubit. So I highly encourage you to go watch his presentation. It's fantastic. It's got all the production values of a high-end keynote from AWS. And the paper that sits behind this work will be released in the near future. So we're looking forward to talking more about the technology that sits behind this logical qubit work that's happening at Pasadena. And of course, we can have a conversation today about that as well. With Braket, so Braket is our quantum computing service in the cloud. We've been operating it for about 3.5 years now in general availability. So it's just like any other service on AWS. We've got compute, storage, databases, and quantum computing in the cloud. It's an environment to build and test and run quantum computing algorithms and also use the tools of AWS to analyze those results and be able to iterate through that so that we can all learn together over time. And the priorities behind Braket really drive this flywheel. Our customers tell us what they need, and we look to drive the innovation through this flywheel. So first of all, democratizing access to quantum hardware. We don't know what quantum computers are going to be the best for particular applications. Our customers want to explore different modalities, different features, different quirks and interesting tidbits of each different device. And so we want to open that up as much as possible and working with our quantum hardware partners to do that. We want to provide choice and say open-minded. We don't know how this is going to play out over the next couple of decades. And so having an open mind, working with the choice in hardware, choice in software, choice in tooling, how it connects across hybrid compute into classical, yeah, that's a big part of our philosophies here. And then also to be a voice of reason for our customers. Our big enterprise customers of AWS, our startup companies, they trust us as an enterprise infrastructure provider to be there over a really long term. You know, they're running their production workloads in the cloud, and so they look to us to be a voice of reason to help them understand what quantum technologies are, how it's going to apply to them, and where it can take them in the future. So providing kind of that trusted service advice, you know, being a voice of reason with them so that they can test and explore for themselves and try out different computers. So today on Bracket, we offer 6 different computers from 4 different providers. We've been delighted to work with IonQ and Oxford Quantum Circuits, Rigetti and QEra over the course of this year in making different kinds of quantum compute available. So each of these computers provided by each of these providers are different. There are different attributes to them. There's pros and cons of working with each of them. And so what we see with our customers is that they're trying out the different hardware. They're exploring how different algorithms perform across those modalities and what the trade-offs look like so that they can think about how this will scale in the future, the intellectual property that they need to do work on, the kind of workforce that they need, and where to take this over time. So our customers in 2023, you know, I'll get to some bigger announcements in a second, but there's all these kind of like quality of life issues. When you're operating quantum computers in the cloud at scale, delivering to customers worldwide every day, there's little stuff. And the little stuff really matters in delivering against that flywheel. So democratizing access to quantum compute, being able to offer a choice in hardware and being a voice of reason, you know, it's these little things that help enable people to get access to quantum compute. I'll just highlight a couple. So localization across 10 languages. This year we launched Bracket in the console and also the documentation in Indonesian, in Korean, in Japanese, Italian. You know, it's helping to spread the access to quantum compute so that anyone, anywhere in the world can access a quantum computer through the cloud. They can get the support they need and the right documentation and start building, start exploring, start doing that work. On our simulators, we upgraded all of the classical infrastructure that sits behind our simulators. So we've got simulators of quantum compute that allow you to test out your algorithms before running on hardware. You're upgrading the classical compute that sits behind that allowed us to run 50% faster, which also means, you know, because we bill on time, that it's 50% cheaper as well. So it's faster and cheaper based on those upgrades today going through the work. And then across all of the hardware fleet, whether it's Rigetti or OQC or QEra or IonQ, we had incremental upgrades to the performance and reliability and accessibility of each of those systems with different features that customers have been asking for. So we're excited to keep doing this. You know, we need your feedback so that our 2024 roadmap includes these kind of improvements as well. So John Preskill mentioned in his opening keynote this morning this study, the end-to-end complexities study, we call it. So this is some theory work that's come out of the AWS Center for Quantum Computing in Pasadena. And this is a body of work. It is about 350 pages. It goes through every quantum algorithm that you could feasibly run on a fault-tolerant quantum computer and looks at the trade-offs of those algorithms. So what are the complexities involved? What do you need to change as you think about how to actually run these, whether it's on a fault-tolerant quantum computer or adapting it to a NISQ-era computer? What we hope is that this paper becomes essentially a guidebook for quantum application development work over time. It's sort of written kind of like a wiki. You know, each section kind of breaks into its own, you know, format, so you can look at quantum machine learning or quantum chemistry, optimization problems, a whole bunch of the canonical algorithms of quantum compute. And so you can explore through this flowchart that I've got on the slide here, you know, from the customer application down to the computational task, into the primitives that it needs to work with, into fault tolerance, and iterate through that environment. And the paper itself is divided into exactly those sections. So if you need to look at just the quantum computing primitives, then you can go to section 10, find exactly what you need, kind of use the guidebook there, understand the trade-offs around those algorithms. So we've been working on exactly those trade-offs with some of our biggest customers. So with Goldman Sachs, the Quantum Solutions Lab team looked at that theory So this is a theoretical work building on the end-to-end complexities paper, looking at a particular algorithm around portfolio optimization. And what they discovered by using this framework and using this paper is that even when an algorithm might show signs of utility in the future, once you dive deeper, once you use this kind of guidebook to explore those complexities, there's a drastically different picture starts to emerge over time. The level of complexity, the level of trade-offs that you need to make as you look to any particular algorithm, it becomes more and more complex. And so that's why these guidebooks are so important to work through these kind of studies. So I encourage you to go dive deeper on this paper. I know some of the collaborators are in the room right now as well, so thank you for your work. A couple of other quick examples of solution providers that are building on top of Bracket. We're super excited about Quantify. Quantify based in Denmark. They're a computational chemistry company that's looking at adapting their algorithms to run on both the quantum and the classical infrastructure that AWS provide. So we just published a blog with them a couple of weeks ago. We had them on stage with us at reInvent last week, looking at an adaptation to VQE to look at some early stage molecules that are going to be interesting to their work. And while there are trade-offs in the complexities there, they were able to demonstrate the feasibility of practical and accurate electronic structure computations on the current NIST devices that we've got. Now, no speed up yet, but being able to fit feasibly these molecules onto the devices and run them at scale is a really important result in comparing across multiple platforms. So in the chart there, we're comparing across our different simulator technologies against the Rigetti Aspen 3 on IonQ Harmony, and looking at the trade-offs that apply practically once you get out of the theory and into the practice as well on a service like Bracket. Not everything is quantum though. Some of the simulations that we need to do at really large scale happen on our classical infrastructure in AWS. So being able to provide high performance compute resources to companies like Blue Qubit, and I won't steal their thunder because they're on tomorrow at 3:30, but encourage you to go take a look at what they've been up to, looking at the super high memory instances that AWS can provide in the cloud. So 18 terabytes of memory to be able to run very, very large scale simulations of quantum compute is some really interesting work. So that's a little teaser for the Blue Qubit team tomorrow afternoon. So please go check that out. Also building on the software libraries that are available. This year, there was a whole bunch of new software layers that got added to Bracket and accessibility across different platforms. And this helps expand that democratization. So it's not only adding language support for different languages around the world, but different frameworks and different tools so that people that are used to a particular environment can start to interact with quantum computing through the cloud. And so one example of that was working with the team at Wolfram. The Wolfram mathematical library now sits on top of Bracket. You're able to work within the Wolfram environment if that's the environment that you love. And you can take something like the Grover's algorithm circuit and implement that through one line of code, then one more line of code to point it to any of the hardware or simulators that run on Bracket as well. So we're really excited for this work that we're doing with Wolfram together. I expect over the next couple of years, we're going to see more and more examples of customers that are working within frameworks like this to run some quantum compute in the cloud. In the research side, MIT is the Ministry of Information and IT in India, and we've been running a quantum computing applications lab with them over the last 3 years. This year, we issued 72 grants to quantum information science research across India. So being able to support researchers, no matter where they are, with access to quantum compute in the cloud, access to classical compute, so that they can do innovative work, build up their workforce, build up IP, do good science. That's what we're about here. And so we're looking for opportunities as well to replicate these kind of frameworks with national hubs, no matter where they are in the world, and get more and more science coming out on top of the resources we make available. Okay, let's talk about the major feature update for Bracket this year. We just launched this last week. It's now in general availability, and it's called Bracket Direct. So up until now, Bracket has been a pay-as-you-go type service on demand, and you submit your circuit, you get in a queue, you might have to wait in that queue for a while and get your circuits run. And also, it's self-serve. You're doing that work yourself. This is what the cloud typically is, for all of our classical compute in AWS. But what we heard from customers was two things. One, they wanted access to dedicated time to reserve in advance to be able to run their workloads and do their experiment in the way that they wanted to do it. And two, to be able to get access to the scientists and engineers that actually built the device so that they could then optimize for their particular circuit and their experiment. And so the Bracket Direct program addresses those customer needs. So you can now get dedicated private access to any of the machines that are available on Bracket. There's no queue. You get that slot for your time to run your experiment. You can connect with the quantum specialists at each of the companies that we work with. And we're putting some of the newest capabilities and highest performance devices available through Bracket Direct, so you can access it there. So all you need to do is log into your Amazon console, AWS console, click on Bracket Direct over on the left-hand side, click on Reserve Device, and you'll be able to access a reservation window. We'll have a discussion with you about how to optimize that circuit. You see on the screen here, we're also starting to now provide direct access to all of the quantum hardware partners and our own team, so you can get access to the Quantum Solutions Lab, office hours through this booking form, or any of the quantum hardware partners that we work with. So it's really meant for our most performant users that are looking to get the most out of all of these devices to get direct access, not only to the hardware, but the advice they need to get the best experiment done. We worked with our quantum hardware partners at IonQ to bring the best available IonQ device onto Bracket Direct as well. So it's available today, a 30-qubit ion trap quantum processor. It's only available through the reservation windows, so you can still access IonQ Harmony and IonQ Aria through the pay-as-you-go self-service model, but to get access to the really high-performance 30-qubit device on Forte, so 3 IonQ devices available on Bracket, to get access to that top tier one is through the reservation window process. And we expect to see more of this over time. As high-performance, scarcely available computers become available, they'll go to Bracket Direct first. We'll drive as much performance out as we can there, learn together what it's going to take to operate these at scale, and to be able to put it onto the self-service pay-as-you-go service. So highest performance devices on Bracket Direct, and then gradually working towards making those more ubiquitously available. A couple of launch customers with IonQ Forte. We work very closely with Kedma to look at error mitigation services on top of Forte. So working with Kedma, they were able to access the Forte device, bring their error mitigation support on there that's software driven, and work directly with the IonQ engineers to be able to get the best performance out of that. We'll have a blog out in the next couple of weeks that describes this experiment and some of the work that they were doing, but some really impressive results of a software company looking at error mitigation, a hardware company being directly involved, and putting all that in a cloud environment as well. One of our global systems integrator partners, Deloitte, we work very closely with them also on direct access through Bracket to get access to the Forte device. And this was a generative adversarial network modeling that looked at image classification, image generation type problem. But what this did for the Deloitte team was give access to the high-performance quantum computer and access to the experts to really dial in how this experiment was going to work and get the solutions from there. So we're delighted to work with 2 very different companies. A startup company out of Israel doing some innovative work in error mitigation, and then one of our top-tier partners at AWS with Deloitte, both looking at how to access these computers through the cloud. So I've covered a lot today in a very short time. I know there's a lot of information coming at you. So one of the things that we launched last week as well at reInvent was a new learning path for Bracket. So this is a self-service, online, virtual, free learning pathway to learn everything you need to know about how to operate Bracket in the cloud, how to access all of those computers. You can earn a digital badge. So it's an official AWS training and certification digital badge. Put it on your LinkedIn profile. And so you can get access to all of these tools, learn how to operate them, be part of that democratized effort to explore quantum computing in the cloud. So I got one more thing. And it's building on top of all of this. So we've got, I explored with you, our researchers, our systems integrators, our enterprise customers, our solution providers, and learning how to use all of these tools on a global effort. And so I invite you all back to this stage at 4:50 today, where we'll be sharing a special announcement with our partners at Airbus and BMW and the Quantum Insider that starts to tie all of this together. So hope to see you again later today to talk about that.